I'm going to start recording. So today's session is primarily going to actually get into Unit 3, but I do want to talk briefly about Exam 2. So Exam 2 is due on Saturday, so if you have not made an appointment, hopefully you get that taken care of before Saturday, and that means everything from Unit 2 is due. So all the homework, all the quizzes, all the discussion boards, and the exam, all of those items from Unit 2, anything from Section 10 to Section 18 are due on Saturday, no exceptions. So that does not count Project 2, right? Project 2 is different. Project 2 is due on the 18th, which is next Tuesday, and that is a hard due date. You get 20 points off for every day late after that. So you can turn in late for some points, but having it done by Tuesday is your best option. Okay. So I wasn't planning on going over anything for Exam 2 in this session unless you have questions. So you've got the the practice test embedded in Ivy Learn, so you can take that practice test. If you work through the practice test, you will probably be okay in terms of the exam. So for those of you that have not taken it yet, if you go into Ivy Learn and find that practice test, that's going to be your best bet. So I would recommend doing that. So do you guys have any questions regarding anything in Unit 2 before we move on to discussing the introduction of Unit 3? Nope, Jessica says no. Okay, and one thing that I want to also kind of put a plug in, it's okay if you wait until after Saturday to start Unit 3, but I want to just point out that from Saturday the 15th to Saturday the 29th, which is Exam 3, is 2 weeks. So in 2 weeks, you're going to cover an entire unit, which could be troublesome. So hopefully, if you take the exam in the next couple of days, maybe if you take it tomorrow or Friday, get started on Unit 3 right away. I'm actually going to put a notice out of potentially having multiple live sessions next week to get as much information of Unit 3 next week as possible, so that last week can be, working on things, finalizing things, and not trying to get new material in. So if we can maybe get all the new material out next week, then that last week can be finalizing details. So we'll see. I'll shoot out some emails on that. But there you go. So we are going to spend the remaining time today talking about the first 2 sections of Unit 3. And I love Unit 3, at least the first part, because it's real world math. If you have been adulting for any number of years, you have probably experienced everything in the first 3 or 4 sections of Unit 3. And I think that makes the math a little bit easier because you live it. And when you're living the math, it's a little bit easier to understand. And when you understand it, it's a little bit easier to apply. So let's go ahead and get into this. So Section 19 is all about credit cards. And I don't have my papers out prepared. Okay, so we've got, pros and cons of credit cards, obviously. And if we were in a face-to-face class, I would make you give them all to me, but it's not as easy in this setting. So, some pros to credit cards, as you guys I'm sure already know, is that you can pay for it on a credit card now, but you don't have to come up with the cash until a later time. And that's really nice if you're buying maybe a $600 couch. I don't have $600 in my wallet right now, but I have a credit card. So, it allows you to buy maybe more expensive things or anything and then pay for it later, which is super, super nice. Another pro, I have 2 credit cards that I use on a regular basis, and they both accumulate points. So I get credit card points, and then I use them to buy Christmas gifts. And that is only a pro if you do not carry a balance on your credit card. Right? So if you carry a balance on your credit card, that would be a con. You pay interest or a finance charge, which is a third bullet. And the reason that's not good is because the finance charge or the fee, the interest, is always going to be more than the value of the points that you earn. So it's kind of like and that's why credit cards can afford to give out these credit card points, because so many people carry balances and pay these huge interest fees that the credit card companies are still making a ton of money. So the con of credit card is that it's very, very easy to get into a big, big debt because you buy a bunch of things because you don't need the money right now. And then that credit card bill comes and you're like, oh crap, it's $1,800. I don't have $1,800. And then you're in trouble, right? So good versus bad credit. Good credit, you get that by paying your bills on time. Yeah, I mean, that's a basic thing. If you pay your bills on time, that's going to get you good credit. Bad credit, skipping bills, not paying your bills, defaulting on loans, those kind of things. The better your credit, the better your interest rate. So if you want to buy a house and you have bad credit, you're going to have a horrible interest rate. It means you're going to pay more in interest. And, that's just not good. You don't want to pay more in interest. So good credit means a low interest rate. So, when I bought my car, I got a 2% interest rate on my car because I have great credit, and it's fabulous. Whereas one of my friends went to buy a car, and they offered her 12% interest. So, you're going to save money by having good credit, and that comes from paying your bills on time. All right, so the credit card fees, there are all kinds of fees associated with credit cards, and there is an example of that in your packet. And then interest is the money you pay on anything that you don't pay off after your grace period. Generally, the grace period is about a month on credit cards, and if you don't pay off your entire balance, you will have a fee. Okay, enough talking. Let's get to some math stuff. So, APR. Does anybody know what APR stands for? And this is going to be crucial throughout the entire third unit. And yeah, Jessica, you're absolutely correct. Annual percentage rate. And the key word there is annual. So the APR is always annual, but I don't pay my car payments annually. I pay them monthly. So we are going to have to do a little bit of math of how to change these annual percentage rates to monthly percentage rates. We'll get to that on the next slide. The next thing to remember is that these are percents. APRs are percents, and we don't play with percents generally, so we're going to want to change those to decimals. All right, let's do some math. So we are going to find the finance charge on a $1,200 balance if the APR is 18.99%. Okay, now we're going to start with this concept, which is APR. The finance charge comes generally monthly. So how do I take an APR, an annual percentage rate, and turn it into a monthly percentage rate? Does anybody have any idea how to go from annual to monthly? Yeah, Jessica's got the whole thing figured out. We're just going to take that first part for now. If you want to take the APR and turn it into an MPR, a monthly percentage rate, we're going to divide it by 12, right? Because there are 12 months in a year. So for this problem, moving on, Jessica did a good job of writing it out for us. We're going to take our percentage rate, our APR. She changed it to a decimal, which gives her 1.1899. We take that APR and we divide it by 12. There's our monthly percentage rate. And you can divide that out and check out the decimal if that makes you happy, whatever. But if we want to find the total finance charge, we multiply then by the balance, right? And that should make sense. The larger your balance, the larger your finance charge, right? If you only carry over $12 on your credit card, your finance charge is going to be pretty small. You carry over $1,200, it's going to be a whole lot more. So what's your finance charge in this case? If you do that math, and you can type this into your calculator just like you see it, 0.1899 divided by 12 times 1,200. What is our finance charge? $18.99. Good. And general rule of thumb, when we're dealing with money, as we are here in these sections, money is always rounded to the nearest penny unless otherwise specified. So good job taking it to the nearest penny. So if this is the finance charge, so you had a credit card, you carried over a $1,200 balance with this APR, the next month your balance is $1,218.99, because not only do you owe that $1,200, but now you have to pay that finance charge. I don't know about you, but $19 buys me a really nice meal at a restaurant. So I don't want to pay that interest. I want to go spend that money somewhere else. Okay, I want you guys to try one of these. So let's go to the next slide. You guys try this one. All right, so we had a couple people with. Oh no, Jessica, you're good. That's the question just said finance charge, so you were fine. Yeah, so the finance charge, again, we take the APR, which in this case is 0.2699, and we divide it by 12. Always APR divided by 12, multiplied by the beginning balance. So when you multiply those to the nearest penny, we get $17.99. So this is the interest or the finance charge. Now, as Jessica's last comment there, if you want to find the new balance is found by adding that to the original balance, which gives you $817.99. And that's going to kind of lead us into the next page. Okay, but finding the finance charge or understanding this APR divided by 12, that's going to be crucial as we move throughout this entire third unit. So, okay, let's go on to the next problem. All right, so I don't like that color. All right, so Sarah has a $1,400 balance with an APR of 20.99%, and she makes no new purchases. She only makes the minimum payment of 6%. So this might be, I actually had a friend once who she wanted to take her kid to Disney. She didn't have any money. So she opened up a brand new credit card just for the Disney trip. She's like, that's all I'm going to use it for, and then I'll just pay it down. So this is kind of like her experience. Although Disney, I think, would cost more than $1,400. So you put $1,400 on, and then you just simply pay the minimum payment every month, and you just slowly pay it down without putting anything else on. So we're going to fill in this table. All right. So part of this, the first three things are what we've already done. So we had a beginning balance of $1,400. All right, let's go ahead and find our finance charge, just the finance charge for right now. Remember, we're going to take our APR, divided by 12, and multiply by that beginning balance, $24.49. And if you have any questions on where these numbers are coming from, please stop me. Okay, so we've got the finance charge. We just practiced that. Now, how do we find the new balance? We kind of talked about that just briefly. We're going to add them together, right? Because the beginning balance is how much you owe. The finance charge is additional. So we're going to take these two columns and we're going to add them together, and that gives us our new balance. So our new balance here is $1,424.49. Okay, now how do we find our minimum payment? Remember, they say up here the minimum payment is 6%. So how do I find the minimum payment for this particular month? We're going to take 6% of the new balance. What does of mean? Times, exactly, Samantha. So we're going to take that new balance of $1,424.49. We're going to multiply by that 6%, 0.06. Okay, so this is going to tell us how much we're paying in that month. So what are we paying in that very first month? $85.47. Perfect. Okay, so just to throw this out there, making the minimum payment only is usually not a good idea. I know sometimes it happens, that's all you have. But if you can pay, even if you just round it up to 86, anything is better than nothing. Okay, so now we have our minimum payment. If we go, think this through logically. You owed $1,424.49. You paid $85.47. how much is going to carry over then to the beginning of the next month? Should be 1339. I'm guessing you probably had a typo there. 1339.02. Yeah, we subtract, right? The new balance minus, you're good. New balance minus the minimum payment gives you the beginning balance. And then we do it all over again. Okay, so then we would take our, our 0.2099 divided by 12, and we would multiply by 1339.02 because we need our new finance charge. And because we owe less in the second month, we're going to pay less in a finance charge, right? $1.07 less to be exact. So you still owe $1339.02. You're paying a little over $23 for a finance charge, which means you're going to owe $1362.44 when the bill comes. So now we take that $1362.44, multiply that by the minimum payment of 6%, and we have our new minimum payment of $81.75. Now this is where I say in the first month, if you could afford to pay $85 the first month, then pay $85 the second month, right? Because even if it only goes down an extra $4, that's huge in terms of the finance charge. It makes a big difference. Okay, and you guys will get to do an Excel assignment which kind of shows this, right? And then again, you'll take that 1362, subtract the 81.75, and you'll go from there. Okay, you will be doing one of these tables, and I believe in WebWork. I don't know if you do it in Excel or if you do it by hand. I'm not sure. Do you guys want to finish the table, or do you feel comfortable with those steps? Jessica says she feels good. What about everybody else? Samantha's good. Caitlin's good. Okay, great. Okay, so that's section 19 in a nutshell, right? Being able to find finance charges and then being able to apply it to a credit card situation. So that's kind of the big deal. All right, so let's go ahead and move on to section 20. And again, if you've been adulting, section 20 will make sense. There's a little bit more math formulas involved in section 20. And on your formula sheet, that yellow sheet, on the back side, right, so underneath the z-score table, there are some random formulas, and those random formulas come from Unit 3. So when you go to take Exam 3 here in 2 weeks, you again will get the same formula sheet because it's got all those formulas on it. So, use that sheet as you're going through all your homework so that you know exactly what you have, so that you can prepare adequately. Okay, so section 20 talks about interest, and we're going to talk about two different kinds of interest, simple interest and compound interest. And simple interest is named simply, and it's pretty simple. So the formula for simple interest is I, this is an I, equals PRT. Now, it's only simple if you know what these things stand for. So, does anybody know what the P stands for? Principal. Good. So the principal is how much you started with. So if you put, okay, wait, let me back up. Section 19 credit cards generally talk about bad interest because you have to pay more. Section 20 talks about interest in terms of good interest, like we put money in a bank or that kind of thing. So if you put $10,000 in the bank, that's the principal. That's how much you started with for your investment. Okay, what does R stand for? Rate, yep. And the rate is generally given as a percent. And so you got to change it to a decimal. And then T stands for what? That's a rough looking arrow. T stands for time. And the big thing here is that time is always in years. So if they would say something about 6 months, well, 6 months is half a year. So time would be 0.5. So you do have to make sure you're paying attention to how many years are you doing this, not just, 6 months. Oh, it's a 6. No, 6 months means half a year. So there's your formula for interest. Now notice, oh, wrong button. Notice that this is the interest. So if the question says, what was the ending balance? Well, then you're going to have to do some more math because this formula doesn't give you the ending balance. This formula gives you the total interest, which is different. Okay, so now let's erase the drawings and do a problem after I change my colors here. Okay, so Sarah invests $600 at 2.5% simple interest for 6 years. We're going to do two questions. First, we're going to just figure how much interest does she earn, and then part B, what is her balance after those 6 years? Okay, so remember, interest is PRT. So for number A, letter A, whatever, interest is, what is her principal? $600, right? Because she invested $600. We're going to multiply that by the rate as a decimal. What is her rate as a decimal? Nope. There you go, Jessica. Yep. We're going 2 places to the left. So 0.025. And then times the number of years, which in this case is 6. So if we take 600 times 0.025 times 6, what is the simple interest? $90. Okay, so she earned $90 on her investment. So after 6 years, her balance is going to be the principal, right? What she started with plus the interest. So she started with $600. We're going to add the interest of $690. So her balance is roughly $690. Okay, so every 6 years, she's earning $90. That's kind of okay, I'm going to give you guys one of these to try. You guys play with Trevor. Trevor invests $2,000 at 1.75% interest for 12 years. How much interest does he have, and what is his balance? All right, so we've got interest of $420, added that to the initial investment, and at the end of 12 years, Trevor has $24.20. Right. So Jessica and Samantha seem to be answering most of the questions. Ryan, Yarley, Caitlin, if you guys have anything to add, please do so. But if you don't ask any questions, I'm going to assume you guys are all doing okay. So let me know if you have any questions. Okay, so that's simple interest, right? Very straightforward. You do some multiplying, you do a little bit of adding, and then you call it a day. So simple interest. So now we're going to get into compound interest. So the formula for compound interest, you'll notice starts with a B, and that B stands for the ending balance. So compound interest is different right off the bat from simple interest in that our formula gives us the ending balance, not our initial amount, or our initial interest, which is what simple interest is. So you'll see a couple of familiar letters, right? Principal, rate, time. Those are all the exact same things in simple interest and compound interest. Principal is how much we start with. Rate is the interest rate in terms of years. And T is time in years. Our new guy is the N. So what does N stand for? Does anybody know? Nobody?
Right. I see a no, so
I hope you guys can't hear that too much in the background. There are people talking pretty close to me. You guys are pretty close. Not number of years. That's T. T is the number of years. N is the number of times you compound in a year. And you'll notice that it's there twice. And it's the same value in both spots. Now, what this means is that sometimes you're going to see something that says you should compound monthly. Okay, well, if I say monthly, how many times will you do it in a year if you do it monthly? 12. So if it says compound monthly, N is 12. If it says you should compound quarterly, how many quarters, right? Quarterly, how many quarters are in a year? 4, exact. Don't use a question mark. Be confident. Yeah. Quarterly, just like there's 4 quarters in a dollar, there are 4 quarters in a year. So you would put a 4 here and you would put a 4 here. Okay, so you have to follow that word after the word compound. I mean, there will be times when you will see compound annually, right? And annually means once a year. So if it's compound annually, N is 1. Those are my favorite because dividing by 1 just R, multiplying by 1 just T. That doesn't change things as much, okay? So whatever word follows the word compounding, that gives you your value of N. Okay, let's do some of these. Assume a $1,200 deposit with an APR of 3.5% compounded annually for 4 years. We're going to find the balance, and then we're going to work backwards to find the interest. Okay, so the key right here is annually. What does annually tell us? Once a year, right? So in this case, we know that N is 1. So I just kind of want to show you what this formula looks like for this problem. So this is part A. The ending balance is the principal, which we know is $1,200. And we know that because that's our initial deposit. Inside the parentheses, we're going to have 1 plus. On the top of our numerator, it's going to be our rate. Well, our rate is 3.5%. Remember, as a decimal is 0.035. And then in the bottom, we have N. Well, in this case, N is 1. Then my exponent is the number of years, 4 times N, which is 1. Okay. Depending on your calculator, some of you will be able to type this into your calculator just like I'm going to write it here. This little caret button thing here, some of you might have a button that says y to the x. You're going to have to play with your calculator to see how it works. And just so that you're aware, the answer to this is 1377.03. If we go through these couple examples and you cannot get your calculator to work, it happens. Do not feel bad about it because sometimes these buttons have to be pushed in a very specific pattern. So if you can't get your calculator to work, all I want you to do is take a picture of your calculator with your smartphone or with somebody else's smartphone and email it to me. And just say, how do I do compound interest on this? And by looking at the buttons, I've seen a ton of calculators. I can tell you the steps. I'll give you a problem and then show you the steps that you need to do for your particular calculator. So please do not hesitate to reach out on that. Okay. Anybody have any questions in part A? Okay. So let's think about this now. We started with $1,200 when we deposited it. At the end of 4 years, we had $1,377.03. How much interest did we earn? How are we going to figure this out? We have our starting amount and our ending amount. How do we figure out my interest? Nobody? To find our interest, we're going to take our ending balance, the 1377, we're going to subtract our principal. Because if I take the amount that I ended with, 1377.03, and I take away the amount that I started with, the difference, and in this case it's $177.03, that difference is the interest. We are assuming in this case that we did not make any additional deposits, which is a big assumption. So assuming that $1,200 was deposited and not touched for 4 years with these pieces. Oh, it's okay, Ryan. So that's kind of our steps. Okay, so ending balance minus the beginning principal gives us the interest. So you can kind of see how mathematically simple interest and compound interest are figured different, almost in opposite ways, because you find interest first with simple, you find the balance first in compound, and go on from there. All right, I want you guys to try one of these. That's the wrong button. All right, so assume a $2,000 deposit, compounding monthly for 8 years with an APR of 1.5%. So this is a little bit differently because now we have compounded monthly. So remember, if it's monthly, that means N is 12. So if nothing else, get your formula set up for Part A. See if you can get an answer. We'll talk about it here in just a second.
When she was coming down the street, we said, "Get a car." Yeah, she was in the car. She said, "Get out the street." But we wasn't even in the street. We was up in the driveway. And then we walked up to the car and we said, "Can we get a mom?" Just a second. She told me exactly what you said to her and what she said to you. I said, "Can I get my mom back?" And she said, "No." And then I was like, "I want to get my name." And she said, "Excuse me, mama." And I said, "Exactly." She said, "I'm okay." Yeah.
Good, Jessica. That's exactly right. Yeah, so this is what your formula should look like. And you'll notice that N is 12, so you've got that in the denominator and in your exponent. And when you type that in, it should spit out at you, as Jessica put in the chat box, 2254.82, rounded to the nearest penny. Is anybody having trouble getting that or not knowing where these numbers are coming from? Samantha, where are you having trouble? Everything on this? Okay. Do you understand where the numbers are coming from in terms of the formula? So we'll call this line L. Does line L make sense? Okay. It might be that your calculator, if your calculator is giving you issues, start inside your numerator or your what is this called? Parentheses. And start here. So you might want to start with saying, you know what, 12 times 8 is 96. So I can say, instead of having two numbers up here, I'll just have 96. That might be easier in some of your calculations. So then you want to work inside the parentheses. So order of operations says I should divide first and then add. So if you would take 0.015 divided by 12 and hit equals, then hit plus 1 equals, then we want to take it to the exponent. So that's where you're going to want to either use your caret or your y to the x button, one of these two buttons, and then 96 equals. And then the last step would be to multiply by 2,000. Some calculators, that's kind of the way to do it. Okay, good. So sometimes, you gotta type things in different spots. Okay, good. Anybody else kind of need a talk through or a discussion? And with these, the more, you do a couple of these and you get comfortable with typing things into your calculator, and you're just going to feel a whole lot more comfortable with it. Okay, now how do I find my interest? How do I find my interest? We've got our ending amount here, 2254.82, and we're going to subtract. Exactly. So remember, interest is balance minus principal. So 2254.82 minus the $2,000 that we started with. So our interest is $254.82. Okay. All right, I want you guys to try another one of these because, again, the more you do, the easier they get. So, okay, let's go with, we got a deposit of $600 with an APR of 4%, and now we're compounded quarterly. So remember what that means, quarterly, for 30 years. So you're going to find the balance, you're going to find the interest after 30 years. All right, so we've got an answer here, and it is correct. So looking at your balance, okay, so your formula, you're looking for the balance. Principal, how much did I start with? 600. Inside my parentheses, 1 plus the rate. The rate's 4%, so that's 0.04. We're going to divide that by quarterly, means n is 4. And then the exponent up here is 4, because that's the value of n, times those 30 years. As Jessica mentioned, 1980, 23. Who has questions? Who needs help? Let me throw a $sign in here. Everybody doing okay? All right. Let's then go to part B. If I ended with 1980-23 and I started with 600, what was my interest? Yep. 1380.23. You more than tripled your money. And this kind of, well, this will lead us into next week, which we're going to get into retirement. $600 is not a ton of money to put in the savings account thinking I'm going to grow it for later, but just $600 for 30 years more than tripled. So imagine if you would just put $50 a month in after that, and how much bigger it would get and how much faster it would grow. So we'll get into those kind of things when we get to the 401ks in a future section. But that's kind of what we're getting to, right? It really grew. You got a lot of money out of it. It's not like you're doing anything with it. It just sat, right? Which I like to have part of my savings account where I know I can't touch it. Doesn't matter what happens. That's just savings, because I know that over time it can really grow if you just let it sit for a while. Although not with the interest rates right now, they're pretty shitty. But that's life right now. Okay. Any questions going through compound interest? We just have one more concept, and then we're done for the day. I would like to talk a little bit about next week if possible. But, all right, so we're going to talk about the rule of 70. Sometimes you'll also see this as the rule of doubling. So those two are kind of interchangeable. So the key is when you see the word double, how long will it take for something to double? You're going to use the rule of 70. And the reason it's a rule of 70 is because the formula is right here, 70 divided by P. That's where the rule of 70 comes, because it uses 70. Now the key here is that P is a percent. So if I would say we have a 6% rate, then it would be 70 divided by 6. And that's how we would figure out how many years it would take to double. And that's different than what we normally do, because normally we take that percent, we change it to a decimal. Well, not in this case. We take that percent and we just chuck it right into the P. That's why it's a P, not an R, right? R is a rate. Rate implies that percent has been changed to a decimal, where the P just says this is a percent. There's your difference, okay? And we can use the rule of 70, or the rule of doubling, to calculate anything that will double, assuming that the growth rate is an annual growth rate. That's the key. It has to be an annual growth rate. So, moving on to our problem here. How long will it take for money to double in an account if the APR is 5% compounded annually? Notice it doesn't matter how much money we have. Whether you have $20 and you're doubling it to 40, or you have $6,000 doubling to 12,000, it doesn't matter. Okay? So doubling is doubling. It doesn't matter how much you start with. And this is approximate. These are not exact. These are approximate. The key, though, is that it's annually. So we're going to use 70 divided by P. In this case, our percent is 5. So we would take 70 divided by 5, which gives me what? 14. So if you have an account, oops, that was a bad circle. If you have an account that you have an APR of 5% compounded annually, no matter how much money you start with, it will approximately double in 14 years, which is fabulous. I mean, 14 years is not that long when you think about it. Well, I feel that way now. I didn't feel that way 10 years ago. All right, okay, you guys try one of these. Oops, wrong button. Population of the U.S. increases at a rate of 0.7% each year, right? Jessica, no. If you, oh shoot, here we go. If you were to think about multiplying by 100, if you would take that 0.05, take that 5% and change it here, then multiply it by 100, that's how that works. But because the formula is given as 70 over P, the P stands for percent as a percent. And that's because 0.05 times 100 is just 5. So you get back there anyway. We used to teach it like this, which I liked because that's percent to a decimal, yes. But you end up back at you're at a percent. So you just take 70 divided by the percent, and that gets you. Yep, exactly. It's a little bit different than what we're used to, but we got to kind of roll with the punches. Okay, so the population of the U.S., if you increase, and this is each year, right? That's the annual concept, because each year is annually. So, and this is accurate that the U.S. population does grow at approximately a 0.7% each year. How many years will it take for the population of the U.S. to double? $100. You guys are correct. So 70 divided by 0.7 gives you 100 years. And this is accurate data, people. In 100 years, which we'll all be dead, but I mean, your descendants might not be dead. I don't have any, so whatever. But it's going to double. We're at like 325 million, and places are pretty packed now. So imagine in 100 years when there's 650 million people living in this country. I mean, that's just Montana is just going to be flooded. The Dakotas are going to be flooded because there's nowhere else for people to go. So it's kind of a crazy, crazy thing. So that is the end of today's session, which we've got 15 minutes. Technically, we can end early, of course. But does anybody have any questions over credit cards, simple compound interest, rule of doubling, exam 2, anything like that?
Yes, correct. Tell me what it changed to. It changed from June 2nd, 2017 to October 29th, 2016. We had experienced a miscarriage.
Okay, so no questions. If you do, that's fine. I'll stick around after for a few minutes, but I'm going to be sending out a message. It'll probably be an announcement because it's the easiest way to communicate, although some people don't read those. That's okay. About next week. We'll do our normal session on Wednesday, 1 to 2, doing sections 20, 21, 22, 23, 24. And then I would like to hold another session either Thursday or Friday doing the other 4 sections, 25, 26, 27, 28, or maybe 2 additional sessions and breaking them down. But I would like to do that next week. That way it takes some pressure off of that final week with there being so much to do and so many assignments. You have finals. I would like to, if that's possible. So, and I'll still hold that last week session, of course. But just keep an eye out for that. If you'd like to give me your opinion on that, feel free to shoot me an email and we'll kind of go from there. So if you guys don't have any more questions, we're done for the day. So thanks for coming at this special time. And I'll see you guys in a week. Jessica, I think there is. You know what? Let me write myself a note on that because I'm not going to be doing this conversion until after I leave here. So it won't go on until probably about 8 o'clock tonight. But I know there is a video. I just don't know where it is. So I'll post the video of the credit card, Excel, and any other Excel videos that you need. I'll post them all at the same time. So there'll be one announcement with all of the video links. Thanks for reminding me because I like to do that and sometimes I don't remember. Yeah. Anything else? And you're welcome. All right. I'm going to go ahead and stop recording, and thanks for coming, everybody.